It's the most iconic feature on the largest planet in the solar system. The Great Red Spot, a storm larger than Earth that has raged on Jupiter for over 300 years. But recent data tells a surprising story. This ancient tempest is shrinking, and scientists are racing to understand why. The Great Red Spot is essentially a superstorm, a high-pressure system unlike any on Earth. It rotates counterclockwise in Jupiter's southern hemisphere, with winds peaking at over 430 km/h, 267 mph. It's big, it's violent, and it's mysterious. And yet, it's fading. Why? According to recent observations from Earth-based telescopes and NASA's Juno spacecraft, something in Jupiter's atmosphere is slowly tearing the storm apart. In May 2017, astronomers using the Gemini North telescope detected a small, hook-shaped cloud breaking off from the storm's western edge, followed by what looked like a wave peeling away on the eastern side. It wasn't just a glitch, it was a pattern. Juno's high-resolution cameras captured red flakes, pieces of the storm's outer layers being torn away and flung into the atmosphere. These events, observed more than once, suggest that Jupiter's atmosphere is destabilizing the storm from the outside. That raises a critical question. Could the Great Red Spot actually disappear within our lifetimes? Some models suggest it might shrink to the point where it's no longer visible, or at least no longer recognizable as the massive oval we've seen for centuries. And while that might seem sad to space lovers, scientists are thrilled, because this gives us a once-in-a-lifetime opportunity to witness planetary-scale weather evolution in real time. But what exactly is causing this? The leading theory involves zonal winds, the same bands that dominate Jupiter's atmosphere. These powerful currents, moving in opposite directions across latitudes, may be siphoning energy away from the Great Red Spot. As the winds change speed and position, they interact with the edges of the storm, chipping away at it like waves eroding a coastline. Another possibility involves heat gradients. Jupiter emits more heat than it receives from the Sun, and this internal energy drives much of its atmospheric motion. Changes in heat flow from the interior could be altering the stability of long-lived storms like the Red Spot. Whatever the cause, the decline is measurable. In the late 1800s, the storm measured over 40,000 kilometers, 25,000 miles wide. Today, it's closer to 16,000 kilometers, or 10,000 miles. Still massive, but less than half its original size. Its color has also changed, shifting from a deep brick red to a more muted orange. This might be due to changes in chemical composition or exposure to different radiation levels. Still, the red spot remains powerful, continuing to rotate and trap atmospheric material within its walls. It's shrinking, but not yet dying. In fact, some researchers believe it may stabilize into a smaller, long-lived cyclone, much like the one seen at Jupiter's poles. The Juno spacecraft has given us unprecedented insight into the depth of the red spot as well. It's not just a surface storm, it extends hundreds of kilometers deep into Jupiter's atmosphere. Juno's microwave and gravity instruments confirmed that the storm penetrates much farther than previously thought, possibly connecting to deeper layers where heat and motion originate. That means this isn't just a cloud pattern. It's a vertical engine, tapping into Jupiter's internal energy, and still very much active, though evolving. The Great Red Spot also plays a role in heat distribution. By stirring the upper layers of the atmosphere, it helps transfer heat from the planet's core outward. As it shrinks, the effects on Jupiter's weather systems could be significant, changing wind patterns, storm frequencies, and cloud formations across the entire southern hemisphere. Back at Infinity Beyond, scientists are using Juno data to build simulations of Jupiter's future. Some of them suggest that if the red spot does vanish, it may reform elsewhere or give rise to multiple smaller storms that follow similar paths. After all, Jupiter is a stormy world. It has the fuel to generate new monsters at any time. So, should we worry? Not really. The disappearance of the red spot is not a threat to Earth or the solar system, but it is a rare cosmic event, one that gives us a glimpse into the lifespan of weather systems on gas giants, systems that make Earth's hurricanes look like gentle breezes. The bigger takeaway is this: even the mightiest features in our solar system are not eternal. They are born, they evolve, and they fade. And thanks to modern technology, we get to witness that cycle from afar. The Great Red Spot has been a symbol of Jupiter's power for centuries. Its legacy will continue, whether it persists for another 100 years or fades within a decade. But for now, it still spins, a scarlet eye gazing out from a world of gas, storms, and gravity.